The next thing we want to talk about with functions is what do you do with their graphs? How do their graphs change? And you've already seen this in college algebra or algebra 2, but we want to review what the different types of shifts, reflections, and stretches that we'll see. So right now we're going to focus on the shifts horizontally and vertically. The big thing we have to remember here is that horizontal shifts are always the opposite of what you think they will be, and this throws us off sometimes. So that when you see something like f of x plus c, we're actually going to the left even though that's a plus sign. And when you see the negative, it's actually to the right. So watch out for those two. They're very tricky. Verticals are normal for us. They're what we think. Outside is up, negative is down. Okay? So for us, when we say f of x, that's the function. And c indicates how many units we're shifting in a particular direction. So we want to describe the type of graph you are dealing with, then describe the shift. So when we're talking about the type of graph, we want to look at it and say, what's the overall parent function or operation that's happening? Overall, we have something being squared. So this would be your x squared function or your quadratic. Here, there's nothing happening to our x. It's just x, or the linear. Here we have x cubed, and so on. So describe the type of graph we're dealing with, quadratic or parabola, linear or cubic, and then the types of shifts. When we say shifts, we don't just want to say, oh, there's something happening here with my 4. We want to specifically say which direction we're going. Because it's inside the function, it's going to be a horizontal. Your horizontals are your insides. And your verticals are your outsides. So inside, we're moving, again, opposite of what you think, left 4 units. If we're to look at a graph of this on our graphing calculator, we can say here's the quadratic, and I've made it a bold line for us. And then we have the x plus 4 squared. That's going to be our normal line. So if we look at these, here's our first one. This is the parent, and this is the shift. 4 units to the left. This one here, linear, there's a 4, but notice that there's no parentheses. It's not inside anything. It's on an outside. So this is going to be a vertical shift of up 4 units. Again, on our graphing calculator, the parent function, the original linear, and then this is our x plus 4 up there, moved up. This one here, again, the 6 is not included with the cubing. The cubing is only affecting the x. After you've cubed the x value, then you're subtracting 6. So then you're moving it down 6 units. Versus this one in example D, here you have an x, but before you cube it, remember PEMDAS, order of operations, you're subtracting 2 from the x, then cubing it. So this has a change happening inside, and then you have, after the cubing, something outside. So this one is cubic, but it's being shifted 2 units to the right. Again, the inners are always opposites, and 6 units up. Let's check that one. So we have x cubed as the original, then x minus 2 cubed plus 6. The original cubic, and then our transformation. You can see how it's gone up 6 units, and it's also shifted sideways 2 units. This one here, the overall function is your square root function. Inside the square root, we have 4 units, so we're heading right 4 units. And then after the square root function, we're going to shift the entire graph up 2 units. square root function, square root x minus 4, close the parentheses for the square root, then we have, just check it really quick, plus 2, yes. The original, and then the change happening right up there. Last one is your absolute value function. This one is being taken to the right 3 units and down 2 units. This one, the absolute value function, this is in your math under number and then abs. So let's make sure that we know how to graph that one with our graphing calculator. So back here, math, number, abs, x. Math, number, abs, x minus 3, close the parentheses, minus 2. So let's make this one a bold one. We'll graph. There's the original absolute value function, shifted down and over. Yep. Okay.